Welcome to the 2023-2024 school year. I'm Mr. Yu. This is a science class, and our first lesson this year is going to be about atoms. Why? Because that's what everything is made out of. It's the building blocks for everything that you see. And to understand chemical properties, physical properties, chemical changes, and physical changes, we need to understand atoms. So, get ready for your lesson on what atoms are all about. Enjoy. So, let's start. I'm going to start same as yesterday. Okay, we're learning about the periodic table of elements, and we're also learning about the atomic structure of the atom. Okay, now why are we doing this? Because it's important, right? Does anybody know what is made out of an atom? What's made out of an atom? Yes, Katie. Everything. Everything. Whether it's alive, not alive, right? Everything is basically made out of atoms, okay? And therefore, well, if you know atoms, then you can know more about everything else. So it's very important. And high school, college, so you need to know all this stuff. It's a good thing to be ahead of everybody else, right? So, in an atom, we have 3 subatomic particles, right? So we got 3 subatomic particles. And what were the 3 names, which you guys already know? Alvin? Proton. Proton, beautiful. We got proton, right? That's that big blue dot I drew last time. It's probably, I might make him a little smaller today so I have more room since I'm going to do more. Electron, beautiful. And that was a small little dot. And the last one? Neutrons. Neutrons, beautiful. Okay? Neutron. Now, when talking about the atom, there's pretty much 2 main parts to it, or 2 main structures in the atom, right? So what was one of the main structures that we talked about? Does anybody remember? Okay, Shri? The nucleus. So the nucleus is the center. Right? So the nucleus is the center. And which atomic particles, subatomic particles, sorry, is in the nucleus? Davey?
The proton and neutron.
Excellent. So in the nucleus, we only got protons and neutrons. Where's the electron? All right, Davey, finish it up. In the electron cloud. Beautiful on the outside. All right. So we have the nucleus and electron cloud, which is the outside, right? And that's where the electron is buzzing around. What was the charge for the proton? Say it. Just say everybody. Positive. Positive. Awesome. What was the electron? Negative. What was the neutron? Neutral. No charge, right? That's why it's a neutron. No charge. Awesome. All right, so we got the basics down. Now let's talk about, creating it, right? So we did this yesterday. We know the first one. All right, so here is one, and bam. I'll draw it here. Bam. So what's the name of this?
A proton.
Well, we got a proton, we have an electron. What is a proton and electron called? What's the name of it? Hydrogen. Awesome. So our first element. Element number 1. Well, actually, let's do this. Number 1 is hydrogen. Does hydrogen have any neutrons?
No.
Why not? Why doesn't it need a neutron? Shouldn't it have it? I mean, all the other ones have it? Abdel, your hand was up first. Davey, you can go second.
The proton and electron cancel each other the charges out.
That is true, but that still doesn't tell me why there's no neutron or not. Davey?
Because the proton takes up all the space.
No, not really, but it's a good try. I like it. It's a good try. Well, what does a neutron do? Do you remember what we talked about? What's the purpose of the neutron? You remember?
It's like to keep the protons from
Yeah, it's to keep the protons together, right? So they don't split apart. It's kind of like super glue, right? So my question to you is, how many protons are there? There's only 1. So is there anything to keep together? No. So you don't need it, right? So in this case, you don't need it. So On average, hydrogen atoms have 1 proton, 1 electron. There's no need for a neutron. All right? All right, let's make it a little bit more complicated now. Okay, so what's that? 2 protons, 2 electrons. Yes?
Helium.
Helium. And is this correct? Did I draw it correctly?
Yes. No.
So what's missing? Katie? 2 neutrons. Yes, 2 neutrons. Whoa, wrong color. So my question to you, Katie, is how did you know that? How did you know it needed 2 neutrons? Why isn't it 1 neutron?
Because helium has the atomic mass of 4.
Oh, you're so good. Nice. Atomic mass of 4. So if you look, the atomic mass has to do kind of, you can think of it as like weight, right? The mass is the weight, and there's 3 subatomic particles, but only 2 of them count for the atomic mass or weight. So which 2 are going to count for atomic mass? Davey?
The proton.
Exactly. So when you have an atomic mass, I'll put it in brown over here. Atomic mass, only the protons and the neutrons count. Why don't the electrons count? Aren't they there? All right, David, finish it up.
Because they weigh really less.
Yeah, well, yeah, they have very little mass, right?
Ryan
Very little
and
mass.
Nathaniel
Good.
Cabrera to the main office.
So they have very little mass, so we kind of ignore them. Think of them as your hair on top of your head, right? Just because you get a haircut doesn't mean you're going to lose a few pounds, right? So we kind of just can ignore them. We don't even include them in the atomic mass. Are we good so far? Any questions? I'm pretty sure everybody's got this so far. It's going to get more complicated, but if you have a good foundation and a good base, you'll be all right. You'll be able to read all the elements, and you'll know exactly what it means. So we got number 2 is helium. Now, above the symbol, right, there's a number, atomic number. So what does the atomic number tell us?
The amount of protons in it.
Amount of protons, correct. So if I want to go to element number 3, what's element number 3 called? Everybody?
Lithium.
Lithium, okay. And what's the atomic number? 3. So, how many protons does it have?
3.
Awesome. So I'm going to draw a 3rd proton now. How many electrons? 3. Yeah, if it's got 3 protons, we're going to do 3. We're going to do 3. Don't draw anything yet, because there's a reason for it, okay? So the question is, it's got 3 protons, 3 electrons. But look at the chart for a second. Hydrogen and helium are at the top, highest row. But then lithium starts at the 2nd row, and they're called periods. You can see it on the side right here. It says periods 1, 2, 3, 4, 5 goes on to 7. So why would you need to start it on the 2nd row? Why don't you just put it right behind or next to element number 2? Gaia.
Because it's a metal.
Well, you're not wrong. You're not wrong in terms of it is different than helium and hydrogen.
Numbers on the bottom. Does that have to do with it?
No. Yeah, Davey?
Because it's like how many electrons are in like each orbital.
It's not orbital. They're not called orbitals. Yeah, orbitals is different, okay? So what happens is atoms, they have energy levels or energy shells. So I'm going to erase this 3rd one. The first energy level or energy shell, right? So I'm going to put, this is our energy level. Or shell. It's also known as energy shell as well. But level is the more common one, but I've heard and seen shell. So energy level or energy shell can only hold 2 electrons. Can't hold any more. Can't do it. So where does the 3rd one go then? Somebody I haven't heard from yet. Come on, anybody new? No? So it's the same people raising their hand. Yes? It goes to the 2nd energy level. Yeah, so I got to draw a 2nd energy level now around my atom. And that's why it goes to the 2nd row. Because it has 2 energy levels. So guess how many energy levels all the atoms in the 3rd row have? 3. because that's why it's like that. There's a reason for it, right? It's not done at random. What about the fourth period? How many energy levels does the fourth period atoms have? 4 energy levels. 5.
5.
Okay, 6. And 7. So therefore, if you're ever not sure or you forget, just look at the periodic table and you'll know exactly how many energy levels it has. So I would have to draw my third electron on the second energy level.
What about the numbers on the top?
We're going to get there. But right now, we're going to do basic. So Gaia asked, what about the numbers at the top? Those are called groups. That is going to make things a little bit more complicated. We are not there yet. I want to keep it simple and get a good, strong foundation. Because yes, it does get more complicated. There's a lot of stuff to learn about it. But if you learn how to read the chart, it's very easy. You'll figure it out. Okay? So we're going to keep it nice and simple right now. So we got 3 protons. We got 3 electrons. What about my neutrons? Does my neutron count good? No? How do you know? What's the atomic mass for lithium? Well, yeah, it says 6.9. We can't have half an atom or a part of an atom. So we round it to 7. So if the atomic mass is proton plus neutron, and we have 3 protons, but we need to get to 7 because atomic mass is 7. So how many neutrons do I have to have? Everybody?
4.
Yes. All right, 4. So I'm going to draw 4. Now, you guys ready for a challenge? I'm going to give you a little challenge right now. I think you guys can handle it. So I'm going to give you what? I think 2 minutes is enough time for you to draw an atom real quick? I want you to draw element number 4. And then we're going to do it together and let's see if you did it right. So I'm going to give you 2 minutes. Go ahead, take your time. Just draw it real quick. It doesn't have to be large. Just draw it small. I want you to draw the energy levels, the protons, the neutrons, and electrons into your notebook right now. So let's get the simple things out of the way. I think the simple things would be the protons and electrons, right? Wouldn't that be the simple part? So would anybody like to tell me how many protons? Yes, Sam?
4.
4. So we got 4. So we'll draw 4. Okay. I'm going to leave a little space here because I don't want the proton. I want to spread out the protons a little bit. So I'm going to put a little space here. So we got 4 protons. How many electrons?
None.
You say no electrons? 0? So I got to erase my red dots then?
No.
Okay, so try again. Try again. How many? It's okay. How many? Try again. 4, right? If there's 4 protons, there's going to be 4 electrons, okay? So we're going to put 4 electrons. It's okay. Like I said, it's the first day, well, technically day and a half that we're doing this. So we're going to learn this. Don't worry. This is going to be easy after a while. All right, so I got 4 protons, 4 electrons. Now comes a little bit challenging part. How many neutrons? Anybody new I haven't heard from yet? Can I get some new voices? Yeah, in the back. Go ahead.
5.
5? How do you know it's 5 neutrons?
Because the atomic number
Not the atomic number.
the atomic mass.
The atomic mass is
9.
9. So,
And we already have 4 protons, so we need 5 neutrons.
perfect. We already have 4 protons, so now we just need 5 neutrons, and then we'll get it. So 1, 2, 3, 4. I have to draw a 5th neutron. And now we have beryllium. Pretty easy so far, no? All right, so what I want to do now is I'm going to skip a little bit. I don't want to go through 5, 6, 7, 8, 9, 10. It's going to take a lot of time. So I'm going to skip. So we went to beryllium. Now I want to go to oxygen. Let's go to oxygen. Let's go to element 8. Okay? So again, try drawing oxygen. I'm going to draw it too in a little bit. And I want to tell you the answer and see how you do. Again, oxygen is element number 8. All right? So let's go with Nico. How many protons, Nico?
8.
8. How do you know that, Nico?
Because the atomic number is 8.
Yes, the atomic number is 8. Awesome. So we got 4, so I'm going to draw 8. I'm going to spread it out a little bit because I don't want it on top of each other. And we haven't even done the neutrons yet. So we got 1, 2, 3, 4, 5, 6, 7, and 8. How many electrons? Nico, finish this up. How many electrons?
8.
8. Sweet. So do I put it in the first energy level?
No, the second.
Why can't I put it in the first one?
That's the nucleus.
No, the first energy level, the inside one.
Oh yeah, you can.
I can?
Yeah.
Okay, how many did you put in the inside one?
I put 4.
You put 4 in the inside one and 4 in the outside one?
Yeah.
Am I allowed to do that? Can I do that?
No.
No? Well, why not? Why can't I put what he said, 4 and 4? All right, we'll go Gaia and then Shri and then Dave, you get third if they don't get. Go ahead.
It's only 3 per energy shell.
So Gaia says I can only put 3. 3 is the most I could put in each energy shell?
I'm pretty sure that's what I heard.
That's what you heard? Who told you this?
I'm pretty sure I can't really remember. I think it was 3 or like it was 2. The 3 or like something, like 3.
Okay, but you didn't hear it from me, did you? Just want to make sure.
I don't you said something, but I don't know if it was 3 or like some other number.
Okay, all right, so you say you might have forgotten, but you're not sure. All right, so Shri, what do you got?
2.
2 in the first one?
No, like, yeah.
2 in the second one?
No, two in each.
Oh, so 2 and 2.
No, so based on how many, so you need like 8 electrons, right?
I do need 8 electrons, yes, that is correct.
So for each energy, you would draw an energy shell per 2 electron. So it builds up after.
So you're saying I need to draw a third energy level?
4. You have to draw.
I have to draw 4 energy levels?
Yes.
Huh, interesting. I have to draw 4 energy levels. But didn't we say that each row tells you how many energy levels there are? So if you look at oxygen, which row or period, they're called periods. I apologize, I don't want to say rows. But I just want you to understand that periods mean rows. So they go side to side. So my question is, oxygen is in which period? Oh, Davey, I said you can go third. So Davey and then Sam if he doesn't get it. Go ahead, Davey.
It goes in like the second period. And
It's in the second period. So how many energy levels will it have?
2.
So we know that oxygen has to have 2 energy levels. It can't have 3 or 4. Right? The chart tells us this. That's how you gotta read the chart. Right? Every element in the second row, second period, has 2 energy levels. There is no ifs, ands, or buts. There is no, today's Friday, I feel like getting a third one. It's 2. Okay? So, Davey, now I said you have the third try. So, where do I put my electrons? On the first energy level, second energy level?
On the first energy level, and you put 6 on the second energy.
So you're saying put 2 and then 6 on the outside. And why can't I put like some in the first one?
Because 2 will fill up the first energy level.
Exactly. The max for the first energy level is
2.
2. So I'll write it here so you don't forget it. So first energy level, right? The first one, max is 2. You can't have more than 2 electrons on the first energy level. You can't. It's just how it is. It's, Why? I don't know. Science doesn't know. We don't know. But we know that there's 2 electrons on the first energy level, and that's all there is to it. Gaia and then Shri and then Alvin.
Can there be more like the farther it goes? Like do the numbers go up?
That's a good question. So we put 2. So Davey said 2 in the first one and then 6 on the outside. So let me put 6 on the outside. So I got 2 out here. So 3, 4, and I'm spreading them out. Remember, they're negative, right? Electrons are negative. So what happens when you put a negative and a negative together? They're going to repel each other away from each other. So don't put 6 right next to each other. That's just not how it is. They're all spread out and they're whizzing around the nucleus. So we got 1, 2, 3, 4, 5, and then I'll put 6 over here. So now I got 6. Do I have 8 total electrons? Then it's good. 8 protons, 8 electrons. Shri, you had a question?
Like, what do you mean by like the periods on the periodic table of elements?
Okay, that's a good question. So, the rows.
Oh, okay.
Yeah, the period. So if you look here, also over here, right, they have the same thing. 1, 2, 3, 4, 5, 6, 7. So the first row, hydrogen and helium, they only have 1 energy level. The second row, right, we got lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. They only have 2 because they're in the second row. Second period. The rows are called periods. I don't know why they didn't call them just rows, but they just said periods.
And what about the ones that
I guess they felt like being different. I don't know. I'm not gonna. I mean, yeah, I don't know. I don't know where the word period came from for naming the rows that way, but that's what they're called. So that's what we're gonna call them. Who is third? Alvin, you were third.
I had the same question.
You had the same question? Perfect. Sam?
What's like the 1, 2 through 18?
Okay, so those are the groups, and I said that's going to make things more complicated, so we're going to save that for later. Right now, we're doing the basic, easy stuff right now. And then later on, once we have our foundation set, then we can do more complicated. It's all good. It's all good. Everybody did a good job so far. All right, so we got the electrons, we got the protons. Now let's take a look at the neutrons. Right, so how many neutrons does oxygen have? So we got the atomic mass. Right, I think I even have a picture of it. Yeah, so we have the atomic mass. What?
That's so cool.
Okay, cool. So, somebody new. Come on, somebody I haven't heard from yet. Before I give a second try to say yes. Yeah, you.
8 neutrons?
8? How do you know it's 8?
Because it's 16.
16 is the atomic mass. Would you round it? Yes. But you still didn't tell me how it's 8.
Well, 16 minus the atomic number, which is 8, is 8.
Okay, you're absolutely right. Yeah, so I have to draw 8. So I got 1, 2, 3, 4, 5. So I got to draw 3 more neutrons. So 1, 2, 3. And now I have oxygen. And that's oxygen.
Wow.
Okay? Guys, if you have questions, please say something, all right? Don't sit there quietly and try to figure it out. It doesn't matter what you think, you know. Just ask. It's okay to ask. All right, so 2 questions, and then we're going to move on to a more complicated one. Yes, Alvin, and then Judith.
Why are there 6 electrons?
On the outside?
Yeah.
That's a great question. Why are there 6 on the outside? So let's take a look at the atomic number of oxygen, right? So how many protons does oxygen have?
8.
So how many electrons must it have?
8.
8, right? So how many are we going to put in the first energy level? 2. And how many are we going to put in the second energy level?
6.
So what's 6 plus 2?
8.
So don't we have 8 electrons? So then we're good then, no? Right? Good question. Judith. All right, does everybody understand that? He asked me why, your question was why don't we have 8? Or why do we have 6 on the outside? So why do we have 6 on the outside, right? We need 8, but there's 2 in the inside one, right? So remember, it's the total number. So total number of protons, total number of electrons has to equal the same. Again, some of you might be like, well, Mr. Yu, I heard this and that, and you're 100% right. There are exceptions. I don't want to make it too complicated. We're going to get to the complicated stuff further down the road. Right now, we're just doing basic structure, basic protons, neutrons, electron counts, and that's it. We'll do more stuff later, okay? Judith, yeah.
How do you know how many electrons are supposed to have?
So, Judith asked, how many electrons is it supposed to have? How do you know?
The next one is 2.
Right? Sam, you're going to go ahead?
How many protons are on it?
Yeah, by the atomic number. So if there's 8 protons, how many electrons must it have? 8. So think of a magnet, right? So if we have a proton is positive, electron is negative, the atom itself, it wants to be neutral overall, the charge to be neutral. We want a 0 charge. Okay? So if I have 8 positive magnets and 8 negative magnets, they're going to cancel each other out, and you'll have a nice neutral energy field, so to speak. Right? So that's why it's 8 and 8. Does that make sense? Right? You don't want too many positive or too many negatives. Again, we're getting into the more complicated stuff, which is going to happen later on, so I'm not giving too much information right now. Let's keep it basic and simple. All right, one more. All right, 2 more questions, and then we're moving on. Shri and then Nico.
So it's like, so the first shell has 2.
The maximum is 2. It can have 1. If it's a hydrogen, it can have 1, but the maximum is 2.
And then the second energy shell, it's like, it has a capacity of 8.
Correct. The second one, so the second energy, and I'll put it over here, second max is 8.
And then, but what about for like the other shells, for like other elements?
Exactly. Great question. So let's do one. Let's do an element that has extra energy level, right? So let's do sodium. Sodium is element number 11. So let's do sodium. We'll do that real quick. this. Sodium is element number 11. All right, so since it's number 11, how many protons? Everybody. 11. So let's draw 11, right? So I got my blue. I got 8 already, so I got to draw 3 more. So 1, 2, and 3. So now I have 11 protons. Yes? Are we good so far? How do we know that we have to put 11? Why do we have to put 11? What tells us that we have to put 11? Everybody.
The number thing.
The number on top, right? Because that is the atomic number, right? So if you look here, the atomic number, this is the number above the letter, the symbol I should say, they're called symbol, but yeah, it's a letter, is 11. So if there's 11 protons, how many electrons? 11. It has to have the total same number. Are we good with that? Because I feel like some of you guys are still looking at me like, oh, I'm not sure. Do you understand why it's 11? Yes. Question?
We're doing number 11, right?
We're doing sodium, element number 11, yes. Sodium is element number 11. It's capital N with a lowercase a. Yes?
What happens if there's too many positives or negatives?
Again, you're making it more complicated. That's for later. It's a great question. 100% great question. And yes, there is times when it's not going to be the same. We're just not there yet. Okay? So yeah, we're going to get to that. So you're 100% right. But again, we're going to keep it simple. So we got 11 protons. We understand why. Now we need 11 electrons, right? So I got 2 on the inside. I got 6 on the outside. How many more can I put on the second energy level? Just say it.
2.
Well, if I have 6 on the outside right now, the max is 8. So how many more do I have to put? 2 more. Excellent. Beautiful. So I'm going to put 2 more dots. Now, if you look at sodium, is it still in the second period? No. It's not in the second period, right? It's in the third period, which tells us 3 energy levels. So let's draw a third energy level or energy shell. Now, I don't want to go into my writing, so I'm going to try and, finagle it a little bit to make it all fit. All right? Now, how many electrons in the third energy level? All right, Nat, what do you got?
It's 1.
It's 1. How'd you know that?
Because it's on the chart.
She's not wrong. Okay, Nat, can you explain it to me? Because I don't know how to read the chart, and I was never taught how to read the chart. Can you explain to me why there is only 1 on the outside? Don't know? Oh, that's no good. We gotta learn this then. So who can explain to me why we have only 1 on the third energy level? Why are there 11 on the outside? Oh, ¿por qué? Yes. Yeah.
Well, the first energy level only has 2.
First energy level has 2, correct?
The next energy level has to have the remaining 8.
The second energy level has 8, perfect.
And then that leaves only 1 left.
And then only there's 1 left. So 2 plus 8 is 10, which means we need to have 11. We need to have 1 more, so we're going to add it to the end. So Natalie, tell me, why do we only have 1 on the third energy level?
Because the rest of them are on the other energy levels.
Yes, that is correct. The rest of them are on the energy level. So we got 2, we got 8, and now the third energy level has 1. Pretty good, right? Yes, Abrar.
What's the max for the third shell?
The max is 18. Again, I only told you that because I didn't want to lie to you or anybody here. But, Abrar, it's starting to get a little complicated now. We're out of the simple of the simplest, okay? So we'll learn more next week, okay? It's okay. Have a good day, guys.